Hi everybody, I'm Blair DeWitt, founder of Lunar Station. We're based here in Cambridge and we're an MIT startup. We organized in 2016, and at the time of organizing, what we wanted to do for the aerospace market was to solve the data problem of the moon. What we quickly heard from industry was that there was plenty of data, but there wasn't a lot of insights. And so when we thought about it, like, okay, this is the data structure in NASA's planetary data system. It's a PI-led architecture, and we quickly understood why aerospace companies were having trouble just accessing the volume of data about the moon that's already existed. So we set about to create systems that could go into the planetary data system and all the various nodes, extract and ingest that data, fuse it, and produce insights. And that's how MoonHacker came into existence. With MoonHacker, we have a way of characterizing the moon in new ways. And we can help our customers with site selection, surface transit mobility solutions, mineralogy and mineralogy heat mapping. We also get into the astrodynamics. Where's the sun going to be? Where's Earth? That affects your power and comms. We also get into environmentals. What are the thermals? What are the ranges of those thermals? What are the meteorite interactions with the surface and your area of operation going to be? And then finally, radiation. How much exposure are you going to have because you're farther away from all the shielding? And another discovery was that clients had a lot of radiation questions. And understanding that radiation testing is critical, because you get to figure out how you'll survive, what's your availability of the equipment, establishes costs. Can you buy COTS, rad hard equipment, or do you have to build your own? And also, side note, for anyone working on government contracts, it is required for your PDR and CDR. The problem with this is that the National Rad Lab infrastructure is challenged. We were on the phone with a DoD branch talking last week about an 18-month delay now. The workforce is aging, it's not being replenished fast enough, and there's a backlog. So we had a client who's ready to launch, but they haven't gotten their Rad Lab certified. So we were able to put their system in our simulator and move them along in the process so that they can actually meet their launch window. And the way we go about doing our radiation simulator is, first, we create a digital twin. The dimensions, the materials, the shielding. And from there, where are you going to go? Because this is not exclusive to the surface of the moon, orbiting the moon. It is anywhere in space. So our client, being an advanced propulsion system here in the Boston area, it was all over the place because they're actually an engine that will take you from any kind of cargo or payload from one place in space to another. So there was a lot of different places they needed to make sure they could operate without any critical failure. Once we know where your place in space is, we set about in the bombardment. This bombardment can be hours, but we've had clients ask us for 2 decades worth of bombardment. And this bombardment's influenced and modeled after advanced particle research facilities like CERN, Fermi, and here at MIT. Once the bombardment's done, we can then tabulate all those results. Looking at dosage exposures, Cs or single event upsets, but ultimately what the client really wants to know is what's the lifetime expectancy and are there any critical parts that will take my system down? And then we can make modifications to the digital twin as corrections are made and run it through again without leaning on any challenged infrastructure in the nation for physical rad lab. A funny thing also happened along the way. When we were characterizing the moon, we saw symmetry in how underwater domain is also developing. A lot of autonomy, a lot of data generation, not a lot of intelligence. So what's interesting is that the moon actually is better mapped than the ocean. The moon has better resolution, if you could believe it, and more thoroughly photographed. So there's a lot of opportunities for our algorithms to interplay between the two domains. So What we're looking for and what we want to partner with are organizations that need to get to space timely, and let us help you with your radiation testing. Again, I'm Blair DeWitt, and come see us at our table across the hall. Thank you.